Hello, highly esteemed viewers. Welcome to our mathematics tutorial for today. In today's mathematics tutorial, we are going to consider the factorial equation, this factorial equation. And it's a factorial function, and this is an Olympiad exam question. We are going to find the value of x in this factorial equation. But then, if you are new to this channel, don't forget to give this video a thumbs up. Also, subscribe to my channel. Also, remember to press the bell icon. Yes, the bell icon, so that you'll always be notified whenever I upload my daily Maths Olympiad Simplified Solution question. Thank you. Now, let's go straight to solving this question. From the question, we are asked to prove that this whole factorial question, we are asked to prove that this whole factorial question, which is this whole question, this whole equation is equal to 21. And to prove that, we need to find the value of x. Now, how do we go about that if we are asked to find these various values? Stay put as we are going to find a solution to this question. But then, before we solve this, remember we are dealing with factorial. The question now is, if we have a factorial, what is a factorial? Factorial is the product of all whole numbers from the choosing numbers down to a 1. Now, if we are treating factorial, we have a value like 6 factorial. 6 factorial is the product of all whole numbers from 6, that is 6 multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, and multiplied by 1. So all whole numbers, multiply all whole number, choosing from that 6 down to 1 is a factorial of 6. Now, to solve this value we have been given, which is 2 to the power of x plus 3 factorial, divided by 2 into bracket 2 to the power of x plus 1 factorial is equal to 21. We want to prove that this will give us 21. So how do we do that? First of all, we are going to find the value of x. Now, the first thing we are going to do is to find how to clear this denominator, which is 2. And to clear that denominator, we have to multiply both sides by 2. So if we multiply both sides by 2, we are going to have 2 to the power of x plus 3 factorial divided by 2 to the power of x plus 1 factorial, and that will be equal to 21 times 2, and 21 times 2 will give us 42. So all these will give us 2 to the power of x plus 3 factorial divided by 2 to the power of x plus 1 factorial, and that will be equal to 42. So having cleared that 2, the next thing we will now look at doing is to express this value in the form of factorial. Remember, factorial is the product of all whole number from our choosing number down to 1. Remembering that this same value can also be reduced to the factorial. So if we reduce the numerator to using factorial method, the principles of factorial, we're going to have 2 to the power of x plus 3, which is the first product we'll get, and then we'll have 2 to the power of x plus 2, which is the second product we'll have, and then we'll have 2 to the power of x plus 1, which is the last product we'll have, factorial, and all of them will be divided. That's where we'll stop, because you come to see that it has a common value with the denominator, which is 2 to the power of x plus 1 what factorial, and this whole thing is equal to 42. So having seen this, you come to see that this will clear off this, and what we'll have remaining is 2 to the power of x plus 3 multiplied by 2 to the power of x plus 2, and that will be equal to 42. Now, there are two good methods through which we can simplify this equation. We either multiply the left-hand side and then set the equation to become a quadratic formula, a quadratic equation, and then we'll solve quadratically for the values of x, or what we'll do next is to look for two consecutive values, because these values are just like consecutive value. We have 2 to the power of x plus 3 and then 2 to the power of x plus 2. We'll now look for two consecutive values that will give us 42, so that the left-hand side will be consecutive values and the right-hand side will also be consecutive values. So if we look for those two values in 42, 2 will go in 42 to give us 21, 3 will go here to give us 7, and then 7 will go to give us 1. So if we multiply this, that will give us 6 times 7. So 6 times 7 will give us 42. So what do we do? 6 and 7 are consecutive numbers. So if we have 2 to the power of x plus 3 multiplied by 2 to the power of x plus 2, both of them will be equal to 6 times 7. So find out that these are consecutive values. This 2 to the power of x plus 3 is a value that will come before 2 to the power of x plus 2. And then after you start counting, if you can't finish counting 6, you count what? 7. So since they are consecutive numbers, we are going to do something. We are going to equate the consecutive numbers. And for us to equate the same consecutive numbers, 2 to the power of x plus 3, we equate it to 7, and 2 to the power of x plus 2 will be equated to 6. Now, this will give us 2 to the power of x equal to, if this comes over here, 7 minus 3, and this will be equal to 2 to the power of x. That will go over there, 6 minus 2. And if you look at those two equations very well, you find out that our 2 to the power of x will be equal to 4. So this will give us 2 to the power of x will be equal to 2 to the power of 2. Since they have same base, our x will be equal to 2. So x equal to 2 is a value that satisfies that equation. Since we've gotten the value of x to be equal to 2, remember we are asked to prove that this whole thing is equal to 21. So how do we go about proving this? Now let's go down to the question. We are asked to prove that this whole thing is equal to 21. So given the initial question, we have 2 to the power of x plus 3, all factorial, divided by 2 multiplied by 2 to the power of x plus 1 factorial. We want to prove that it's equal to 21. So what we are going to do is to substitute value for s into this expression. So we'll have 2 to the power of 2 plus 3 all factorial divided by 2 to the power of, into bracket, 2 to the power of 2 plus 1 all factorial. What will it give us? Now let's simplify that. If we simplify that, this will give us 2 to the power of 2 is equal to, this will give us this is going to give us 4 plus 3 factorial, and that will be equal to 2 multiplied by 4 plus 1, which is equal to 5 factorial. So this whole value will give us 7 factorial divided by 2 to the bracket of 5 factorial. So if we apply factorial, which is the product of numbers, whole numbers from a choosing number down to 7, that whole equation will give us 7 times 6 times 5 what? Factorials, because that will be the last part we're going to end. It's still continuous. And then we'll have 2 multiplied by 5 what? Factorial. So this 5 factorial can clear the 5 factorial. We'll be left with 7 times 6. And 7 times 6 will give us 42 divided by 2. 42 divided by 2 will be equal to 21. So you see that that whole value which we've gotten, which is equal to 2 to the power of x plus 3 all in bracket factorial divided by 2 multiplied by 2 to the power of x plus 1 factorial is equal to 21. So that shows that x, which is equal to 2, satisfy that equation. It satisfies that factorial equation. This is all I have for you for now. Thanks so much for watching, and do remember to share this video with your friends and colleagues. Don't forget to subscribe to my channel so that you can continue getting simplified mathematics Olympiad solution. Bye bye for now.